The objective of this section is to go ahead and find a tangent line to a curve. Okay, so let's just take a random function. We'll call it f. Okay, so we'll let the y values be equal to f of x. Now, I don't really know what this guy looks like because it's arbitrary. So let's just draw a function in. I'll make it look like what you have in your book. Okay, so there's our function line. Now we're going to pick a point on that curve, and we're going to call it something. We'll call it P. It doesn't matter what we name it as. Now our goal in this course is to try to figure out what is the tangent line. What is the line that passes through the point P and is tangent to the curve f of x. Okay, so I've got this curve right here, and I've got this red line. So the red line is the tangent line. Okay. Now what we need to do is we need to find what we want is an equation for that tangent line. Here's the problem. The issue is that in order to get the equation for the tangent line, in order to get an equation for any line, you need 2 points. And the reason that we need the 2 points, okay, is to generate the slope to tell us how much we're changing from one point to another. So really the slope describes the line, the behavior of the line. So the problem is we need 2 points on the red line. We only have 1 point on the red line. We only have P. So here's what we're going to do. We're going to grab another point that's just a little bit away from P. We're going to call it Q. And we're going to let it also be on the function. So what I'm going to do is I'm going to grab a point Q somewhere up here. I don't know. And it can be on the other side too. It doesn't really matter. This is arbitrary. And what I'm going to do is I'm going to connect those 2 dots together. Now the green line is what we call a secant line. It's not the tangent line. Notice the green line is obviously not the red line, so we'll call this a secant. But, and here's the important part, if P and Q are really close, oops, okay, so if they're close to one another, then the secant line is a good approximation of the tangent. So if Q was even closer, let's say Q is down here, and then we drew the green line through it, it would be really close to the red line. That's the idea. And so what we'll do in the next couple chapters is we're going to take those 2 points, we're going to take Q, and we're going to squish it. We're going to squish it towards P as close as it can possibly get. And then we're going to use that to determine what our tangent line is. So let's take a look at these 2 guys right here. Well, to figure out the green line, and we can figure it out now because we got 2 points, we need to give P and Q x values. So let's just call, and we'll make them arbitrary, let's just call this guy A and this guy B. So that means that P is A units over this way, okay, and Q is B units over this way. Okay. Now what are the heights? Well, you might look at this and say, oh, I don't know. But if you look here, this value right here falls on this curve right here. So that means P is at a height of f at A, right? Because if we take A and we plug it into this function, we should fall on the blue line. And likewise with q, if we plug in b into the function, this guy is at a height f of b. So now we can figure out the equation of the secant line. So the equation of the secant line is given, well, first let's do the slope. The slope of the secant is equal to f of b minus f at a, over b minus a. So this is the difference in your y values, y2 minus y1, over the difference in your x values, x2 minus x1. That gives you your slope. And then what we would do is we take that slope value out, okay, we plug it into the form y is equal to mx plus b. This would be our m value. We would solve for b using one of these 2 points to plug in for y and x, and that would give us the equation for the secant line. Okay. Now we're going to go ahead and do this in some of the problems that follow. So this is just an introduction. So the idea is we want to get an estimate for the tangent line. We're going to pick a point that's also not on the tangent line but also on the curve, move them closer together, and then that'll give us a good estimate for the tangent line. Okay, so that's the process.